In this example, we're going to look at the chain rule to find the derivative of 3t squared minus 7t all raised to the 11th power. And I'm going to do it in three different ways. I'm going to use the z notation, or the fill the box notation, or the in your head notation. And I don't think a student should usually do it three ways. You should pick the way you like best. But I just want to show how it looks. And it may help even if you use like the z notation to look at one of the other ways. It might help you see where z goes. Alright, so here's the z notation. And I'm going to start by writing the chain rule in Leibniz notation at the top, just to kind of remind me what the steps are. So at some point we will need to find the derivative of y with respect to z. That's dy over dz. And at some point we'll need to find the derivative of z with respect to t. That's dz over dt. And I'll also just remind you what the formula is. Y equals 3t squared minus 7t all raised to the 11th power. Okay, so let's start by identifying z and how that would allow us to rewrite y. So z is the part inside, 3t squared minus 7t. And if we replace that stuff with z, then we can write y equals z to the 11th. So those two equations break down the original formula for y. But the two equations are simpler to take the derivative of, so that's what we do. Let's start by taking the derivative of y with respect to z. So the 11 comes down in front, and then we subtract 1 from the power. So it's z to the 10th. Now let's take the derivative of z with respect to t. So the 2 comes down in front of 3t squared, and that leaves you with 6t minus 7. The derivative of 7t is just 7. And now I combine this using the formula at the very top, dy over dz times dz over dt. So it's 11z to the 10th times 6t minus 7. Now my final step is just going to undo the substitution we started with by replacing z with the original 3t squared minus 7t. And that'll be my final answer. 11 times 3t squared minus 7t raised to the 10th power, all times 6t minus 7. Okay, now let's do what I call fill the box notation. And what this means is you write the original rule for the derivative using a box instead of x, and then you imagine putting something inside of that box. So here's the power rule using a box. So the derivative of box to the n equals n times box to the n minus 1 times, and this is why it's the chain rule, the derivative of whatever is inside of that box. That last step is what makes it different than the usual rule with x. Okay, so now I'm going to rewrite that with the power that we have in this problem. That's to the 11th power, so the derivative of box to the 11th, and so on, 11 times box to the 10th. And I'm going to put the stuff that's inside of this formula, the original function rather, I'm going to put that inside of the box. So let me actually make it a little bit bigger to make room. And then inside of that I will put the 3t squared minus 7t. So that's what I mean by fill the box. Whatever you wanted to put inside there, the chain rule would still tell you to do the same thing. Whatever you put in on the left, you would have it inside the boxes on the right. Now there's one step still to finish. That last formula has box of 3t squared minus 7t prime, and that means we still need to take that derivative. I haven't taken it yet, that's why the prime is still there. Once I take the derivative, I will not write the prime. Okay, so one more step, I'll write that out, and you have 11 times 3t squared minus 7t to the 10th times 6t minus 7. We're at that last step. I took the derivative, and of course I stopped writing the boxes. Okay, let's do it one more time with what I call notation in your head. And I want to be very careful here. I'm not going to try to encourage people to do more in their head, or maybe I should say not too much more. So maybe you like the box notation, or maybe you like the Z notation. By all means, keep using it. But at least looking at the notation in your head helps remind you kind of what the main steps are, and maybe see through the notation a little bit. Okay, so here's what I mean by in your head notation. We take the derivative of the outside, we don't change the inside, and then we multiply by the derivative of the inside. And I usually color code these so that as I write the formula, I can show you which part I'm looking at. So I'm going to color code them so that the outside is red, the inside, the part that I'm not changing, is blue, and then multiply by the derivative of the inside is in green. Okay, so here's the original formula again, the derivative of 3t squared minus 7t to the 11th. Let's start by identifying the outside and the inside. So the outside is in red, that's the parentheses to the 11th power, and the inside is in blue, the 3t squared minus 7t. So let's see, I should start by taking the derivative of the outside. Okay, I'm going to write that with an equals sign, equals, and then the derivative of the outside would be the derivative of parentheses to the 11th. So the 11 comes down in front, and then I subtract 1 from the power. That's the derivative of the outside. The next step is don't change the inside. So what I mean by that is on the right hand side where I'm doing my work, I'm going to write the inside, but I won't change it. I'll just rewrite it there, copy and paste. So 3t squared minus 7t is still on the inside. And then I should multiply by the derivative of the inside. So that's multiply by 3t squared minus 7t prime. And again, the prime is telling me I still need to finish taking that derivative. It means the derivative, but I haven't shown yet what that is. So of course I need one more step, and it's 6t minus 7, as we knew it would be because of course we've done it twice already. So that's the end. I hope that you pick whichever notation you like best. But even if you're using the Z or the box, that the colors here kind of help you see which parts go where.